All right, I'm going to be going over the EPA Section 608 Type 1 with you. You can follow along and put the answers down as I go. I'm going to start with question number 1 on this practice test, and this test will be on Canvas for you, okay? Number 1 says, which hydrocarbon or HC refrigerant is approved for retrofit into existing household refrigerators? So your choices are HC R600, blended HC R441A, or hydrocarbons are not approved for retrofit applications. So retrofit means that you take the refrigerant out of an appliance or a system and you replace it with a different type of refrigerant that is compatible with that system. And HC refrigerants, they have a flammability rating. They're very flammable. So if you use an HC refrigerant in a system that is not rated for flammable refrigerants, you could possibly have an explosion or a fire. So the answer to this question is hydrocarbons are not approved for retrofit applications. Okay, so you cannot pull the refrigerant out and put a hydrocarbon in that system because it may explode or cause a fire. Number 2, equipment which is used to recover CFC, HCFC, and HFC refrigerants from small appliances for the purpose of disposal must meet what standard? Okay, and this is one that you're just going to have to memorize. Okay, when you're pulling refrigerant out of a system that the compressor doesn't work, you have to get 80% of that refrigerant out. Okay, so if it has an inoperable compressor, then you have to get it down to 80%. Okay, you got to get 80% of the refrigerant out. Or if the compressor is running, then you have to get 90%. So the answer is recover 80% of the refrigerant with an inoperative compressor and 90% of the refrigerant with an operative compressor. Number 3, which of the following best describes low-loss fittings on refrigerant recovery devices used to recover CFCs, HCFCs, and HFCs? And the answer to this question is they can either be manually or automatically closed when disconnected to prevent loss of refrigerant from hoses. Okay? So they can either be manual valves that you turn yourself, or they can be automatic to where they shut off whenever you take the hoses off. Number 4, what type of certification is required for persons recovering CFCs, HCFCs, and HFCs during maintenance, service, or repair of small appliances? And so if you think of what we're doing, which section we're on Type 1. Okay, so you would have to have Type 1 certification, or you would have to have the universal certification. So universal is when you pass every single section of the EPA certification, and you either have to have that or you have to have your core section passed and the Type 1 passed. So the answer is Type 1 technician or universal technician. Number 5, for which of the following refrigeration systems / appliances would it be permissible to use a passive recovery device for recovery of CFCs, HCFCs, and HFCs? So when you think of passive recovery, you need to think of system dependent. So system dependent recovery machines and passive recovery machines are the same exact thing. Okay, so if you need to think of those as the same thing. Okay, and for this question, the 3 choices are a centrifugal air conditioner, a reciprocating liquid chiller, or a domestic refrigerator. So let's think of which certification we're taking this practice test for, and that's Type 1. Okay, and most of the appliances that are in the Type 1 certification are appliances that you'd find in your house. Okay, so you need to think of what you have in your house. And most people have a domestic refrigerator. Okay, domestic just means a regular, ordinary refrigerator. So for the answer, or for question number 5, the answer is a domestic refrigerator. Okay, number 6. What is the maximum normal charge of HCFC or HFC refrigerant in an appliance that is allowed to use system-dependent recovery equipment? So system-dependent and passive are the same, so you need to think of that, okay? System-dependent or passive means that it uses the compressor that is in the refrigerant circuit that you are pulling the refrigerant out of to pump the refrigerant out, or just it uses the pressure of that system to pull the refrigerant out, okay? And you can only use a system dependent or passive recovery unit on a system that has 15 pounds of refrigerant or less, okay? So the answer to that is 15 pounds or less of refrigerant. All right, number 7. What is the maximum allowable factory charge of refrigerant for type 1 appliances using CFCs, HCFCs, and HFCs? And the maximum allowable charge would be 5 pounds. Okay, so a small appliance is a unit that is factory sealed, and it comes with 5 pounds or less of refrigerant in it. Number 8, any person who opens an appliance containing a CFC, HCFC, or HFC for maintenance, service, or repair must have at least one self-contained recovery machine available for use. The exception to the rules are persons working on, and your choices are small appliances, low pressure appliances, or high pressure appliances. So again, we got to think of which section we're on, okay? So we're on type 1, that is covering small appliances, so the answer for 8 is small appliances, okay? And the self-contained recovery unit, it has a built-in compressor in it. So that is the difference between a system-dependent and a passive unit, or a self-contained, is that the self-contained recovery unit has a means to pull the refrigerant out by itself. Let's see. Number 9. New household refrigerators may be factory charged with any of the following refrigerants except. And this is just one that you're going to have to memorize, okay? And the answer to this question is R404A. Okay, R404A. Number 11. What is the approximate pressure of a storage cylinder of recovered 404A that does not contain any non-condensable impurities and is stored in a room where the temperature is 80 degrees? So where we find this at is on our pressure temperature chart, okay? So you can see right here that 404A is right there below my finger, okay? So you will go down and you will find 80 degrees, okay? And you will go over and you will see that 404A has a bubble and a dew column, okay? And the pressure on the bubble is 175 and the pressure on the dew is 173. And if you look at the answers, the closest one to that is 174 psig, okay? So the R404A is a blended refrigerant, and it has multiple refrigerants in it, so they will boil or condense, or evaporate or condense at certain temperatures, and those temperatures are different from one another, just slightly, okay? So that's why we have two different columns there. We have the bubble and the dew columns. And what you have to do for this question is this: you'll take the 175 and the 173, and you find the point right in the middle of those two, and that will give you the answer for this. And number 11, the answer is 174 psig. So when you come to that question, if you have it on your test, use your pressure temperature chart. Number 12, which condition can cause excessive pressure on the high side of a self-contained active recovery device? So a self-contained recovery device has a compressor in it, okay? And it will suck the refrigerant out, and as it sucks it out, it compresses it just like it does in the refrigeration circuit, okay? So in the recovery unit, they have a condenser built into it that the refrigerant that's coming out of the compressor that is built into the recovery unit, the refrigerant flows through there and condenses, okay? So if you have non-condensables in that condenser, that means that those either air or water vapor, whatever it is that was mixed in with that refrigerant when you pulled it out, that is going to go to the top of that condenser and it's going to take up space, okay? And since that space is took up with the vapor, okay, the non-condensables, it takes up capacity of that condenser. So that means that there's not going to be near as much heat that is rejected from that condenser because the refrigerant's not filling the condenser up all the way full. So if you're not losing heat, then that means that the pressure is going to be higher, okay? So the condition that can cause excessive pressure on the high side of a self-contained recovery device is when there is a large volume of non-condensable gas in the refrigerant being recovered. Okay, that was 12. We're going to go to number 13. Which of the following is an acceptable method or device presently used for monitoring the 80% fill level in a recovery tank? Okay, so this is talking about the capacity of a recovery tank, and it is very important that you only fill these tanks up to 80%, okay? So the way that you can use to find out how much refrigerant it is and to calculate what 80% is by using a refrigerant scale, okay? So that would be us putting the tank on the scale and physically measuring how much refrigerant is going into it, or a internal float device, okay? You will not run into an internal float device on the recovery tank very often, okay? But there's still some out there, so that this is just something that they added in just so if you ever run into one, you'll kind of realize what it is. So the answer to this question, which is which of the following is an acceptable method or device presently used for monitoring the 80% fill level in a recovery tank, is using a refrigerant scale or tank internal float device. Number 14. After installing and opening a piercing access valve, the recovery procedure cannot begin if the system pressure is what? Okay, our choices is 75, 30, or 0 psi. Okay, so if you put a piercing valve on a system, okay, you would put it on a small appliance. There's a piece of copper that they leave there from the factory that's called a service aperture, okay? It's basically just a piece of pipe that you can use a piercing valve to get into the system, okay? So small appliances are factory sealed. That means that at the factory they seal it up to where that nobody can put gauges on it, okay? So a regular homeowner cannot put gauges on it and get themselves hurt, okay? Because refrigerant, when it comes out, it's a really low temperature and you can get hurt really bad with it. So to get into the system after, let's say if a compressor goes out on the refrigerator, okay, we need to get into that system to pull the refrigerant out and change the compressor out. Okay, we would use that service aperture to put a piercing valve on. Okay, so back to the question. After installing and opening a piercing access valve, the recovery procedure cannot begin if the system is at what pressure? And that would be 0 psig. Okay, so if you go to a system and you're wanting to work on it because something's not working, and you put your piercing valve on the service aperture and you put your hose on it and you open up the system and you have 0 psi, that means that there is a leak in the system, okay? Because we set our gauges to 0 psi whenever we have the hoses off the system, okay? So when we set it to 0 psi, that puts it at the atmospheric pressure, okay? So if the gauge is reading 0, that means that the pressure is the same as it is in our atmosphere, okay? So whatever the room is, whatever the area where the appliance is, that is the same pressure. So if it is at 0, that means it's all leaked out, and that means if you try to recover anything, that you're just going to be sucking air into your recovery tank, okay? And we don't want to do that. So if it's at 0 psi, we know we have a leak. We know that we don't have to recover anything. All right, number 15. Which of the following is a true statement regarding a refrigerant that can be used as a direct service drop-in substitute for R22? Okay. A direct service drop-in, that would be something that if we were retrofitting an R22 system, and retrofitting means swapping out to a different type of refrigerant, okay? So there is no direct drop-in substitutes, okay? Because R22 was a HCFC refrigerant, and it used a different type of oil in it, okay, than the refrigerants that we use now for retrofit, okay? The newer refrigerants that we use for retrofit use the POE oil or the ester oils, and those are not compatible with the HCFC. So if we try to use an HCFC in with the R22, then we would have to pull the oil out of the system. Some cases you might have to change out a metering device, but there is no such thing as just getting a jug of refrigerant and putting just that refrigerant in there and it worked properly. Okay, so there is no such thing as a drop-in substitute for R22 or any other refrigerants. Okay, 16. Before beginning a refrigerant recovery procedure, it is always necessary to what? Okay, so the one big thing that we're worried about when we pull the refrigerant out is mixing refrigerants, okay? So mixing refrigerants would lead to us having to have an extra jug, extra recovery tank to put that mixture of refrigerant in, okay? So these jugs cost money, so that would be a tank that you would have to have, okay? You'd have to buy an extra tank just for the mixed refrigerant. Also, whenever you go to take that mixed refrigerant back to the supply house to send it back to get reclaimed, you would have to pay an extra fee to either have it destroyed or to have the reclamation facility to separate all the chemicals and do all that. So that's extra money that you would have to do. You would have to spend just because you mixed refrigerants. So before you start pulling the refrigerant out, you need to know what type is in that system. That way, if let's say we got two recovery tanks, okay, that we got refrigerant in. Say we got R22 in one and we have R410A in the other, okay? If you don't check the refrigerant type that's in that system and you started pulling it out, let's say it had R22 in it and you put it in that R410A jug, then you have just ruined that whole jug of refrigerant pretty much, and you just cost yourself a lot of money, okay? So before we recover refrigerant, we know what type of refrigerants in the system. That way we do not mix. Okay, so know the type of refrigerant in the system. 17. Which condition requires accessing both the high and low side of the system for refrigerant recovery when using the system-dependent passive recovery process? So that means it depends on the pressure of the system or the compressor in the system to remove the refrigerant. Okay, and the reason why we would have to access the high side and the low side would be if the compressor does not run. Okay, so if the compressor is not pumping at all, then we'd have to get on the low side and put a Pearson access valve, and we would have to get on the high side. That way we could access both sides of the system. That way that whenever we pull the refrigerant out, we're not just getting half of it, we're getting the full charge out of the system. Number 18, which recovery equipment maintenance practice should be performed on a regular basis? Okay, so the choices are check vacuum pump for leaks, check recovery device for refrigerant leaks, check amperage draw of recovery device, or check amperage draw of vacuum pump. So when we pull refrigerant out, it's called recovery. When we pull it out and put it in a tank, it's called recovery. And we use recovery equipment, which is either self-contained or the system-dependent passive units. And what you need to do out of these four choices would be check recovery device for refrigerant leaks. Okay, so you need to make sure that your recovery device is not leaking. That way that when you pull the refrigerant out, you're not leaking refrigerant into the atmosphere, or you're not pulling air into the recovery unit and contaminating the refrigerant that you're recovering. Number 19, when a pungent odor is detected during a sealed system recovery and or repair, which of the following is most likely? Okay, and the answer to that is a compressor burnout has occurred. Okay, so a compressor is an electric motor, okay, and in that motor it has windings. Okay, so that's just a bunch of wire that is wrapped around, and there's many turns in the wire, and that wire is coated with kind of a lacquer or kind of a plasticky coating kind of. And whenever something shorts out, or let's say you have acid in the system from not getting all the moisture out, whenever you're recovering the refrigerant or vacuuming the refrigerant out, then what it'll do is it'll eat away that coating on the wires, and it'll short the motor out. Okay, and if you've ever smelled any kind of wires burning, you'll know that there's an odor to it. Okay, so the odor that happens in a compressor burnout comes from those windings and the coating on that has melted and burned off, and that smell mixes with the oil. Okay, so if you smell a pungent odor, a really bad odor that kind of smells like burnt wires, then you know that a compressor burnout has occurred. Number 20. After recovering refrigerant from a sealed system, if nitrogen is used to pressurize or blow debris out of the system, the nitrogen, and the choices are, must be recovered, may be vented to the ambient air, should be returned to the cylinder, should only be used if mixed with R22. So after you recover the refrigerant from a system, you can pressurize it with nitrogen to blow out any kind of debris, or to pressurize the system to leak check it. Okay, and nitrogen is not a refrigerant. Okay, nitrogen is just a gas that we use that it's by nature it is a dry gas. Okay, so we'll run it through the system, and nitrogen kind of helps pull a little bit of the moisture that may be in the system out. And it also when you put the regulator and the stuff on the tanks, you'll see that it has like 2,000 psi in the tank. So we can pressurize our systems to a high level, that way that we can leak check it. So normally I normally pressurize it with the nitrogen to about 100 psi, and I'll show you when we get out in the shop how to know what pressure to pressurize it to. But in any case, when we're using nitrogen to leak check or to dry out the system a little bit, you can vent that nitrogen out to the air, okay? Because it's not ozone depleting, it's not global warming, it don't have a global warming potential, so we can just let nitrogen go, okay? So it's not a refrigerant, we can let it go. 21, which refrigerants can be mixed in an appliance? And the answer to that is refrigerants cannot be mixed. So we cannot mix refrigerants. Okay. Number 22. What acids can CFCs and HCFC refrigerants decompose into at high temperatures? Okay, so CFCs and HCFCs, they have chlorine in them and they have fluorine in them. Okay, so we look at these choices. There's boric and chromic acid, sulfuric and phosphoric acid, or hydrochloric and hydrofluoric acid. Okay, and the answer to this is hydrochloric and hydrofluoric, because hydro means water or moisture. Okay, so the moisture and chlorine would be the chloric. Moisture, if moisture and chlorine are together, they can form hydrochloric acid at high temperatures. Or hydrofluoric, that would be water and fluorine. Okay, so when they mix together, then it can cause hydrochloric and hydrofluoric acids. 23. What gases can CFCs and HCFCs decompose into at high temperatures? And the answer to that is phosgene gas. Okay, phosgene gas. So at high temperatures, we can have hydrochloric acid, hydrofluoric acid, and phosgene gas. Number 24, a very large refrigerant leak can cause suffocation because refrigerants are heavier than air and displace oxygen. So if we have a refrigerant leak, that means that the refrigerant is not going to go up. Okay, it's not going to go up toward the ceiling. It's going to stay down around us, and it's going to push the oxygen away from us, and it's going to take the place of that oxygen. Okay, so that means that if there's a major leak, there's a possibility that you could suffocate. Okay, and so we got to make sure that if there's a very large refrigerant leak, that we know what to do. We know that we need to get to a location that has fresh air. We need to ventilate the area, open up doors, put a fan in the door, whatever it takes. And we just got to know that if we have an accident, if we accidentally cut a line or something and refrigerant starts coming out, we need to know that we don't try to stop the leak, okay, because that refrigerant is going to be coming out really cold. It's going to displace oxygen. We could possibly die. We need to know that if something happens like that, even out here in the shop, okay, we're going to try our best to work as safe as we can, but if an accident happens, we need to know what to do. Okay, so if we have a refrigerant leak, let's vacate the area. If we're in the shop, let's go outside, whatever it takes to get out of here to get to a safe place. That way nothing happens to us. Number 25, permanent safety markings are not required on which of the following areas on a household refrigerator using HC refrigerants. Okay, so our choices are on or near any evaporators and next to any exposed refrigerant tubing, near the machine compartment, on the inside of the refrigerator door, or on the exterior of the refrigerator. Okay, and the answer to that is on the exterior of the refrigerator. Okay, so we wouldn't want to have a big safety marking on the door of the refrigerator or on the side of the refrigerator where it'd be an eyesore. Okay, we want those markings to be where the refrigerant's at. Okay, so the refrigerant's on the evaporator, it's inside the refrigerator, or it's in the machine compartment where the compressor's at. Okay, so that right there covers type 1. Just go through and answer the questions on that are on Canvas, and study. Okay, we got to get this test passed.